Okay, so let's go ahead and take a look at this stuff. So your commutator property, order, does not matter with add and multiply. Associative will be grouping, doesn't matter. And all I'm doing really is I'm just, this is kind of just going over, so I want you to pick a different thing that's not in class. Same thing here. So like here, 5 plus a negative 5 is equal to 0. That would be the inverse property for addition. Same thing here for identity property, 5x. The identity is 0 is equal to 5x. Anything multiplied by 0 is 0. That is your property is 0. So that's 7x, like times 0 is equal to 0. Distributor property, I think you guys could get a pretty good example of that. Reflexive property, x is equal to x. Here, symmetric, if 2x is equal to 6, then 6 is equal to 2x. So it just flips back and forth. Use the numbers. So I'm looking at the numbers like 8, 7 when I go here to identify each property below. So this first one is the property of 0. And then this one is reflexive. This one is distributive. Where's distributive? Distributive was 6. Okay, so that's what you're doing here. And then we're talking about closure property, which was in the notes. Okay, so is the set of integers closed under division? Remember, a set is closed if the operation always produces an element of the same set. So if it produces something outside of the set, then it's not closed. So that means that is a set of integers closed under division? Explain why or why not. So that means if I take two integers and I divide them, do I get an integer? That's the question. So for that, that's for 11, right? So the answer is no, because if I take the integer -5 and 10, -5 divided by 10 is equal to -1/2, and -1/2 is not an integer. All right, and that's it for this problem set.